couple other things with triangles. We can classify triangles based on their angles and sides. So you can give it one word for the angles and one word for the sides. An acute triangle is when all angles are acute or less than 90 degrees. We can't have a negative angle in a triangle, so we don't have to worry about saying between 0 and 90. But every angle has to be acute for the triangle we call acute. What's a right triangle?
One side is a 90 degree angle.
What's an obtuse triangle?
An angle greater than 90?
Mm-hmm. And these are only one, because if you had two, it wouldn't be a triangle. It would add up to more than 180. Okay, we can also classify based on sides. What does it mean to be equilateral? Mm-hmm. What about isosceles? Two equal sides, yeah, one different, two the same. And scaling? Yeah, all of it, no equal sides. So we should know those just so that if I say I have an isosceles triangle, you know what that means. You know that means two of the sides are the same. Or if I say we have a right triangle, we have one 90-degree angle in that triangle. The last piece that we have to write down for triangles is similar triangles. In similar triangles, the corresponding angles have the same measure. So that basically means all the angles are the same, okay? They match up in the two triangles. And the sides are proportional to one another. So if these triangles were similar, A and D would have to have the same measure. B and E would have to have the same measure. C and F would have to have the same measure. And then the sides are proportional. So the sides are usually denoted with a lowercase letter. So this is angle A, so side A would be across from it. Angle B, so this would be side B. Side C, this would be D, E, and F. So it means like if I did A over C, I get the same thing as if I divided the corresponding sides over here. So A over C is equal to D over F. Or you could set up a lot of different proportions, but corresponding sides are proportional. All right, any questions about that stuff? So now we're just going to do some examples, and then we'll work on our practice. So the measures of two angles in a triangle are 33 degrees, 12 minutes, and 26 degrees, 35 minutes. Find the third angle. So how do we do that?
Subtract them both from
If you want, so you're not subtracting with three numbers, yeah, I would probably add these first, just to make life a little bit easier. So if we add our minutes, we get 47. Add our degrees, we get 59. And then we can subtract that from 180. So that's like 180 degrees in 0 minutes. So we have to borrow 79 degrees, 60 minutes. So 60 minus 47, 13. 179 minus 59, 120 degrees, 13 minutes.
Pigtail edition.
It's always the basic.
Yeah.
Isn't it? Is that one okay? In the pictures, DEF and GHI are similar. Find the measures of angle D and E. All right, these definitely aren't drawn to scale. They don't really look like similar triangles, but I'm telling you they are. Because they aren't drawn to look similar, it's really hard to know which angles match up, but that's where this statement is very important. The order matters. Since D is listed first, it's the same as the first angle over here. So D and G would have to have the same measure. So angle D has to be 98 degrees. I also need E. E is the second letter, so it's the second angle over here. So E and H have to be the same. So E is 39 degrees. Is that okay? All right. Given triangles M and P and QSR are similar, find the lengths of the unknown sides. So we know they're similar, that means the angles are the same. We have to set up a proportion. So if I wanted to find this side down here, I could say X over, the only side in that triangle I know is 12. And then I have to pick the corresponding sides over here and put them in the same order. So the top would have to be 10, and the bottom would be 8. Then we can cross multiply. And X is 15, or if you preferred, you might see it written as like side QS is 15. The other side, if I wanted, I could call that Y. So you pick two sides in this triangle, make a fraction. So I could say Y over 12 again. Then you have to pick the corresponding sides in the other triangle. So what would that be? Cross multiply. So Y equals 18. Or you could say side RS is equal to 18. I want to see if you guys can draw a picture for this next scenario. So read it and see if you can set up a picture. You guys have the right picture to start with. We have a tree. I'm slightly disappointed nobody drew a tree. These are boring. We are trying to find out how tall it is, so that's our X. The shadow goes on the ground. Okay, this would be a right angle. Okay, so Samir is 63 inches tall and he casts a 42-inch shadow. So the realization you just had is this triangle's in feet and this one's in inches. That's actually not a problem as long as I don't mix up the units within the same triangle. So as long as both of these are inches and both of these are feet, it's okay. I couldn't have both feet and inches in the same triangle. So then you could do a proportion. How could we set it up?
X over 3 equals 63.
Divide by 42. And we get 57, and that's the height of the tree, and the tree was in feet. Is that all right? Final example for today. Let's say I ask you to solve for x here. I'm going to go ahead and tell you that these angles are the same. Since these are the same in both, that means these would have to be the same in both, so we have similar triangles here. Okay, if I just want to find x as it's written, that's kind of complicated, but what I really have are two triangles. I have the whole triangle. And then I have this smaller triangle in the tip. So in the smaller triangle, I know that this is 50 and this is 120. In the whole triangle, I know that this is x. What's the bottom going to be? Well, 100 only gets me to here, so we'd have to add them together. So it would be 220. Then if I think of them that way, what can we do? You could say x over 220 equals 50 over 120. Cross multiply. Divide. And I'm not sure it really comes out to be nice and pretty, to be honest.
Yeah, 91.66.
6, 7.
Oh.
Try some problems. I did take off one here. But